Hello, so I'm Fisherphone and today I present the series and parallel circuit, and this is a unit that I like the most from physics.
Yeah, so let's begin the series and parallel circuit. So let's start with vocabulary. The vocabulary for section 1 in this unit. First, series circuit. It is a circuit in which there's only one path for the current. Second, equivalent resistance. The same current would exist in the circuit with a single resistor that has a resistance equal to the sum of the resistance of the individual resistor. And third is voltage divider. It is a series circuit used to produce a source of potential difference that is less than the potential difference across the battery. And the fourth is parallel circuit. It is the circuit that has two or more paths for current to flow through. Yeah. So in this sector, in section 1, we will talk about series circuit, parallel circuits, and Kirchhoff's rule. So let's begin with a series circuit. A series circuit is a circuit that has only one path for the current. The amount of current is the same to any component in a circuit. The total resistance of any series circuit is equal to the sum of the individual resistance. The supply voltage in a series circuit is equal to the sum of the individual voltage drops. And equivalent resistance of circuits is our circuit is equal to the sum of the individual resistance of the resistor, and the voltage divider is used to produce a source of potential energy difference that is less than the potential difference across the battery. And from the picture that I put in this slide, it is a series circuit with some resistor, as you can see. And next is I will talk about the parallel circuits. A parallel circuit is a circuit that has several paths for the current. The total current is a sum of the currents through each path, and the voltage drop across the resistor that it chooses to pass through must equal to the voltage of the battery. Equivalent resistance of a circuit is the amount of resistance that a single resistor would need in order to equal the overall effect of the collection of resistors that are present in the circuit. And for the voltage divider, is used to produce a source of potential difference that is less than the potential difference across the battery. And next, I will talk about the Kirchhoff's law. There are actually two main rules or law for this. It is loop and junction. But first I will talk about Kirchhoff's first. His name is actually Gustav Robert Kirchhoff. He was a German physicist who created this rule, two of them. The first rule is the loop rule. It describes electric potential difference and is based on the law of conservation of energy. And the second one is the junction rule. It describes the current and is based on the law of conservation charge. Charge can neither be created or destroyed. And the left picture is quite a simple picture for explaining what is loop and junction. And next is for the essential question for section 1. So first, what are the characteristics of series and parallel circuits? In a series circuit, current flows only one path, but in parallel, current can flow more than one path. Second, how are current, potential differences, and equivalent resistance in series circuits related? The current in series circuit is equal to the potential difference divided by the equivalent resistance. The sum of the voltage drop across resistors that are in series is equal to the potential difference applied across the combination. And the equivalent resistance of series circuit is the sum of the resistance its part. Third is how are currents, potential differences, and equivalent resistances in parallel circuits related. So the voltage drop across all branches of a parallel circuit are the same. The reciprocal of the equivalent resistance of parallel resistor is equal to the sum of the reciprocals of the individual resistance. And next, let's begin the section 2. The vocabulary for section 2 there are five of them. So the first one is short circuit. It is the connection between nodes that force them to be at same voltage, which can cause burn up battery like that. And next is fuse. It is a short piece of metal that melts when too large a current passes through it. And the third one is circuit breaker, which is an automatic switch that open when the current reaches a threshold value. And next is a ground fault interrupter, which is an electric outlet that prevent injuries. And the fifth one is a combination series parallel circuit. Is a circuit that includes series and parallel branches. And this is the safety devices for the it's like about we're talking about like the safety device. First is a short circuit. It occurs when a circuit with very low resistance is formed. And the short circuit can cause the current to be very huge and it's very dangerous. And fuse is a short piece of metal that will melt when the too large it will melt when too much current pass through it. And next is a circuit breaker, which is an atomic switch that open when the current reaches threshold value. And the last one is ground fault interrupter, which prevent injury because it has an electronic circuit that like detects some small difference, like what's going on, like what's wrong, extra pad or like that, and like change the circuit. And next, what is combined series parallel circuit? It's just a simple thing. It's just like a circuit that includes series and parallel branches. And what is ammeters and voltmeters? So ammeter is a device that is used to measure the current in any branch or part of a circuit. And the voltmeter is used to measure the voltage drop across a portion of circuit. And here's the formulas for this unit. For the series circuit is V equal IR, I equal VOR, R equal VOI, and the voltage is equal to V equal V1 plus V2 plus V3, and the current is I series equal I1 equal I2 equal I3, and resistance is equal to IQ equal to R1 plus R2 plus R3, and the power circuit is the first three formulas the same as the series circuit, which are V equal IR, I equal V over R, R equal V over I. But the voltage is quite different. It says VN equal V1 equal V2 equal V3, and the current is all different, which is I series equal I1 plus I2 plus I3, and the resistance is quite different too, because it is like 1 over Req equal 1 over R1 plus 1 over R2 plus 1 over R3. And then the unit of this is volt, voltage, ampere for current, and ohm for resistance. Next is essential questions, like how do fuses, circuit breakers, and ground fault interrupter protect household wiring? It stops the current, therefore the circuit won't be overloaded. And how can you find the current and potential differences in combined series parallel circuits? So you have to find the total resistance and divide to the voltage directly from the source to get to the current. And third, how do you use voltmeter and ammeter to measure potential differences and current in circuits? By connecting ammeter in series with resistors. Voltmeter is connected in parallel circuit to measure voltage. And here's the example I can give you about by using formula I equal V over R. So I'll talk about house heater. Utilize a heating coil with resistance of 10 ohm, right? And find current when it is operated 50 volt. So I use I equal V over R, and it's equal to 50 over 10, right? And so it's equal to 5 ampere. And here's my demonstration about the circuit. So as you can see, for the first half circuit that I built is a series circuit. Yeah, so let's wait for it. Yeah, so I connect the wires to the light bulb, yeah, and then this work. Yeah, and then I decided to put the voltmeter to measure the voltage of the battery. And also I'll cut this part and put the the ammeter inside and between and to measure the current, and then I try to increase the voltage, and what will happen, like the light bulb will have more energy, and also the current will flow more. Yeah. And then next I'll try to make my parallel circuit, which was a little bit more complex than that. Yeah, so let's wait. And yeah, I put ammeter in between, but I didn't connect it yet, the light bulb, the wires. And then another light bulb. And then I'll take the voltage to measure not this part but over the battery again. And yeah, this is a power circuit. And next I'll try to do some like interesting thing, which is a short circuit. Yeah, so let's see what will happen. So this is what happened, like the light battery burns. Yeah. And thank you for listening to my presentation, and hope to see you again. Bye bye.